everyone, and welcome back to ImTechnos. In today's video, we are diving into IAM roles, a key feature that lets you securely access AWS services. Let's say you have an EC2 instance running a web application, and this application needs to store user-uploaded files in an Amazon S3 bucket. One way to allow the EC2 instance to access the bucket is by hard coding AWS access keys in your application or directly on the instance. However, hard-coding security credentials is a serious security concern. If someone gains access to your instance, they can steal those keys and misuse your AWS environment. This is exactly where IAM roles come in. Instead of using permanent credentials, you assign a role to your Amazon EC2 instance. The IAM role has a trust policy that allows EC2 instance to assume the role and permissions policy that grants access to S3. So when the EC2 instance needs to access S3, it internally makes an API call to the IAM role, which returns the temporary security credentials. Using these credentials, the EC2 instance then makes the request to Amazon S3. So what is an IAM role? IAM role is an AWS identity with permissions policy that determine what actions are allowed or denied. Unlike IAM users, roles are not associated with a specific person. Instead, they can be assumed temporarily by trusted entities like applications, AWS services, or federated users. If you are unfamiliar with IAM users, check out the IAM users video linked in the description. And also, IAM roles do not have long-term credentials such as passwords or access keys. Instead, when an IAM role is assumed, AWS issues temporary security credentials for the duration of the session. A commonly asked question is, why are the security credentials called temporary even though the IAM role is permanently attached to the EC2 instance? As discussed earlier, when an EC2 instance makes an API call, the IAM role provides security credentials that allow the instance to access services like Amazon S3. However, these credentials are automatically rotated by AWS at regular intervals for security purposes. Since they are not fixed or long-term credentials, they are considered temporary by design. You can assign roles to EC2 instances, Lambda functions, ECS tasks, and many other AWS services. IAM role have two types of policies, trust policy and permission policy. The trust policy defines which principals can assume the role, such as EC2 instances, Lambda functions, Elastic Kubernetes service, container service, and many others. On the other hand, the permissions policy specifies the actions and resources that the role is allowed to access. For example, Amazon S3 full access, DynamoDB read-only access, and more. Based on the scenario we discussed earlier, let's see how to attach an IAM role to the EC2 instance so it can access S3. First, we will create an IAM role that allows S3 permissions. Then we will launch an EC2 instance and create an S3 bucket. Finally, we will try to access the S3 bucket from the EC2 instance, both with and without the IAM role attached. Now, I'm in the AWS Management Console, working in North Virginia region. Let's start by creating an IAM role. Search for IAM in the search bar and select it. You will be taken to the IAM dashboard. Click on Roles under Access Management in the left navigation pane. Then click on Create Role. Since we are creating this role to attach to an EC2 instance, choose EC2 under the use case and click Next. Under Add Permissions, search for S3 Full Access Policy and select it. Click Next. Give a name to the role such as EC2 S3 Access Role. Scroll down and click Create Role. The role will be created successfully and will appear under the role section. Now in another tab, type and select EC2 in the search bar. From there, click on Instances in the left navigation pane and then click Launch Instances at the top right. Give the instance a name like S3 Access Instance. Choose Amazon Linux 2 as the AMI. Use the default instance type T2 Micro, which is free-tier eligible. Proceed without a key pair as we won't be using one in this demo. Keep all the options as default for network settings and configure storage, and then click Launch Instance. Scroll down, click on View All Instances, and your instance will be reflected in the console. Next, in New tab, go to S3, click Create Bucket, and give it a name like Demo S3 Access Bucket 1234 to make this bucket globally unique. Leave other options as default and click Create Bucket. Now go to Instance page, select the instance we created, click Connect, and under EC2 Instance Connect, click Connect again. Run AWS S3 ls to list the bucket we created earlier. However, since the IAM role is not attached yet, you won't be able to access it. So go back to the instances page, select the instance, go to Actions, click Security, and choose Modify IAM Role. Select EC2 S3 Access Role and click Update IAM Role. Now, in the terminal, run the command again. This time, you should be able to see the S3 bucket. This demonstrates how IAM roles help your AWS resources communicate securely and automatically without the need for manual key management. To avoid unnecessary charges and keep your AWS environment clean, follow these cleanup steps. Go to EC2 console, select the instance you launched, click Instance State, terminate instance, and confirm the termination. Next, go to S3 console, select the bucket you created, make sure the bucket is empty. If not, delete any objects inside. Click Delete, confirm the bucket name when prompted, and finalize the deletion. And then optionally, go to IAM console, find and select the IAM role, ensure the role is not attached to any instance, click Delete Role and confirm. So please note that if a role is used elsewhere, be cautious before deleting it. Let's wrap up with some essential best practices to follow when using IAM roles in AWS. Always grant only the permissions that are absolutely necessary. Never hardcode credentials or use long-term access keys in your code. IAM roles provide temporary, automatically rotated credentials. Create separate roles for different applications or EC2 instances. This helps with clear permission boundaries and easier troubleshooting. Periodically, audit your IAM roles and attached policies. Remove any permissions that are no longer needed. Use AWS CloudTrail and AWS Config to track role usage and detect unexpected behavior, and enable Access Analyzer to get visibility into external access. Prefer managed or customer managed policies attached to roles over the inline policies, which are harder to track and manage. Define specific trusted entities in the roles trust policy. Don't allow just any service or user to assume the role. Lastly, use tags to manage, organize, and identify roles for cost allocation, ownership, or automation. That's it for today. If you have any questions, feel free to drop them in the comments below. Thank you for watching, and I'll see you in the next video. Take care and happy learning.